Ugh. Come on, focus. Hello, everyone. Good morning. Hola. You I don't know what it is about this week, but my eyes are super, like I wake up in the morning and my eyes are just like super baggy. Waiting for about, I don't know, 4 more people to join up. You know what? It's already 4 minutes. I'm just gonna start. All right. Hello, everyone. Let's see. The midterm grades are up. Yeah. So you can take a look at your scores on that. I gave you guys an assignment for. We have 1 assignment per week right now, and so that assignment is up. And yeah, so there's no assignment for today. It's just the continuation of that. All right, so really, this unit is a lot about definitions. So we talked about, we're continuing to talk about networks. And last time I defined several different types of networks, such as LAN, WAN, etc. Okay, so we're just going to go through some additional vocabulary terms today. These are vocabulary terms that might appear on the IB exam if you take it. So the first thing I wanted to talk about is something called the server-client model of networks. So what is a server? A server is basically a specialized computer for a single task. Okay. All right. So, for example, email. You might have an email server. So it's a computer that's handling emails. All right. Something like that. And the client uses the resources. So this is basically like a personal computer. And it uses the resources of the server. Okay, and that's not to say that the client computer can't do anything. I mean, it can do things, but if there's a powerful if there's a powerful computing need, then they might ask the server to do that computation and then send the result to the client. Okay, so you have a I don't know, a switch or something, and you might have clients, client 1, client 2, all these clients, say client N, and then you have a couple of different servers, maybe only one server, but you could have multiple servers in the network, and the clients are requesting services from the server. Okay, so that's called the client server client model. Okay, and so that's a term you should be familiar with. We talked about local area networks and wide area networks. There is also something called an SAN, which stands for storage area network. And so a storage area network is a network where your servers are connected closely to memory. Storage. So you might have the servers are connected to storage. So in a storage area network, servers are connected closely with storage. Okay, so a storage area network is going to be used when you have computations that are requiring a lot of memory. Okay, so I don't know. I would imagine that things like Netflix probably have storage area networks because they have to store all of these, all of their content somewhere. So they would have to have tons and tons of storage for all of that content. YouTube, the same thing. So the servers have to have easy access to all of that content. So a storage area network might be useful. Another thing I was thinking about the other day is, has anyone heard of this new, it's not PlayStation or, it's called like Stadia, I don't know how you say it, but it's supposedly a gaming platform where you can play it on any computer, and has anyone heard of this? Does anyone have it? But I think it follows this server client model quite nicely, where regardless of the specs of your computer. Basically, the server is doing all the computations for the game and then sending it to you. So your computer is not really doing the computations itself. It's just displaying what the server is sending it. So it's kind of an interesting idea. Obviously, that requires only 5 people have it. Huh. Well, we'll talk more about that in the Zoom room because I wanna know more about that. Okay. So there's another type of network. There's something called an intranet. Yeah, save those comments up because I want to hear what you guys have to say about it in the Zoom room. An intranet, not an internet, is basically a LAN, so a local area network. So it's not a huge network, because remember, the internet is classified as a wide area network. Okay, it's a LAN that is connected like the internet, like a wide area network. Okay, so what does that mean? Well, when you have the internet, the internet obeys certain protocols. Okay, so when I say it's connected like a wide area network, what I mean is it uses what's called the TCP/IP protocol. Okay, so it's a network. It's just like a LAN, but it's a LAN that's communicating using the protocols of the internet. So what does TCP and what does IP mean? TCP stands for Transmission Control Protocol. And IP stands for Internet Protocol. So your IP address is your Internet Protocol address. So we talked about the importance of protocols. Protocol is an agreed upon method of communicating between computers. Okay, so how are computers when they communicate going to verify that the message has not been distorted by interference, for example? What's going to happen if it has been distorted, or is the message going to get resent? How fast is the message going to be sent? Things like that are decided by these protocols. Okay, so an intranet is a LAN, so it's a small network that's basically operating like the internet does. Okay, you can also have an extranet, which is basically a portion of a LAN that is accessible by the internet. Okay, so an example I'm thinking of is Amazon. Okay, so Amazon has their own network. Okay, when you go to the Amazon website, you can look at all the things that Amazon has for sale. Okay, so they're allowing you access to a portion of its network. Okay, not the entire network, but just a portion of their network they're sharing with you. Okay, so that's what an extranet is. It's when you allow anybody to come in and look at a part of a local area network. Okay. All right. So I'm going through all my vocabulary terms for today. Here's a big one. Something called a VPN. All right. A VPN is a really useful thing, and it stands for Virtual Private Network. Okay. So what a VPN does is it allows remote workers or remote clients, I'll say, to access a network through the internet. So to access I'll say a local area network through the internet. Okay. So my brother, for example, uses a VPN because he works at an accounting company, and he's working from home right now. So he needs to access all of that accounting data. Okay. So he's working from home. All right. And he needs to access all of the data that's on his accounting company's servers. Okay. So he accesses that from home via a VPN, which he did not do before because he used to work in the building. So he was physically connected to the network before, but now he's not physically connected to the network. So he needs to connect to the network through the internet. Okay, so that's called a VPN, and I should say it allows remote clients to access a network through the internet in a secure manner. Okay, in a secure manner. That's really important. So, how does it accomplish that? It accomplishes it through encryption. So encryption means scrambling the data, encoding the data so that it's in a way that it can only be decoded by the recipient. And it creates what's called a tunnel. So you'll want to know that vocabulary term if you're ever asked about VPNs. Basically, you have a LAN, a local area network, okay? And then here's the internet. And then here is the client, okay? And so when you connect via VPN to a network, a so-called tunnel is created in the internet. So I don't think IB needs you to learn the details of what exactly does that mean, but you need to know the word tunnel and that it involves encryption. Okay? So it's a secure way of accessing a network remotely. I also have a friend who's a scientist, and she needs to access the data at UCR, so that their lab is collecting data. She accesses that data via VPN from home. All right. There is uh, something called a PAN, which stands for a personal area network. Okay. And so really a personal area network, I've got a personal area network set up right now. Okay. So basically I have my personal computer. Okay. And my personal computer is currently connected to my phone. It's connected to my document camera. It's connected to my printer. I'm literally just looking around my desk right now, and I'm looking at everything that's connected. I think that's it. So a personal area network is just, you know, a really, really tiny network of your own computer and all the things that are connected to it. Okay. And then lastly, there is what's called a P2P network. Okay. P2P stands for peer-to-peer. And so a P2P network doesn't obey or doesn't follow the client-server model. Okay. Does not follow the client-server model. So basically it's a network where all the devices on the network are equal. We don't have super powerful server computers doing specialized tasks. Okay. So every device in the network acts as both a client and a server. Okay. So everything is on equal footing. That's why it's called peer-to-peer, because your peers are your equals, right? I'm just looking at my list of terms here that I have to define. So one of the things when we're talking about developing network technology is there's something called network layers. I'm almost done here. So network layers, there aren't really layers to a network, but it's a way of thinking about a network. Okay. And basically it allows certain companies to focus only on part. Okay, so a company might focus on one of the layers of a network. All right, because networks are very complicated. So to have a company that is making products for all parts of a network is uncommon. Okay, what's much more common is that a company will focus on a single layer and develop technology for that single layer. Okay, and so the model that is used in IB, all right, is called the OSI model. Okay, and it has 7 layers. All right. Okay, so the outermost layer is called the application layer. All right, and so those are the programs. So a company that's working on in the application layer is developing programs that the user interacts with. Okay, So an example might be web browser. So you directly interact with the web browser, okay? So this is all right, and then within that we have what's called the presentation layer. So the presentation layer has to do with encryption of data. Okay, so you're using the web browser, and let's say you actually make a request to view a web page or something. Then that web page is going to get sent to you over the internet, and it's going to be sent in an encrypted way. So the presentation layer handles that encryption, that decryption, so that it's secure. All right, so hopefully you can see that these are two different things. The web browser is focused on, making these requests and displaying web pages. The presentation layer is more worried about how are we encoding that in a secure manner to send over the internet. Then there is the session layer. And the session layer manages retransmission of data. Okay, so what happens if the data has been distorted? The session layer is going to, companies that are working in the session layer are going to try to come up with efficient software to manage the retransmission of the data. There's the transport layer. Which has to do with error checking. So an example of that would be the parity check. So for the assignment on Monday, you guys were working in the transport layer. You were checking, you were basically wrote a little program that would do some error checking. Okay, so an important point about these first 4 layers is that these are all software. Okay, but as we get closer to number 1, we start to deal with hardware. Okay, so there's a hardware side of networking and there's a software side of networking. There's then the network layer, which has to do with routers. Okay. There is the data link layer, which has to do with so-called network cards. So what does a network card do? A network card actually transmits the information onto the internet. Okay. So it's sort of like an antenna. Okay, even though it's not an antenna, it's what is actually putting the information into the internet and sending it or receiving it. And then lastly, you have the physical layer, which is literally the cabling of the internet. Okay, so you can make advancements in any of these layers. So obviously, hopefully you can see that a company that's working on web browsers is probably not going to be developing fiber optic cables for ultra-fast transmission of data. Okay, so that's why we're dividing this into all these different layers. Companies are going to work on just one and maybe the adjacent layers. Okay, so I could understand, if a company is developing fiber optic cables for data transmission, then they might be working with the network cards that are actually putting ones and zeros into that cabling, right? So you might work on the adjacent network layers, but you're not going to go work really far away. Okay? So, if you guys take the IB exam, you might be asked about the OSI model of network layers. Okay? So, I think that's my lesson for today. Oh wait, there's one other thing, one other topic which I don't want to forget to mention, which is called the Internet of Things. Okay, and when we say the internet, most of us think of things like YouTube and I don't know, Facebook and Instagram and all of those things that are on the internet. But when we talk about the Internet of Things, this is talking about the physical structure of the internet. So what is the internet actually composed of? So talking about all the computers that are on the internet, all the servers, all the cabling, all that stuff is called the Internet of Things. So that the actual physical things that comprise the internet, not the websites and so on. Okay, so that's my lesson for today. I will see you in the Zoom room.